Why are perfect square trinomials connected to geometry? Imagine building a puzzle where each piece fits perfectly into a square shape. That's exactly what happens with perfect square trinomials in algebra and geometry. When you see an expression like x squared plus 8x plus 16, it's more than just numbers. It's a visual story of a square. A perfect square trinomial comes from squaring a binomial, like x plus 4 multiplied by itself. When you expand that, you get x squared plus 8x plus 16. This is called a perfect square because it can be rewritten as x plus 4 squared. The reason it's called perfect is because it's a complete square with no leftover parts. Now, think about a square with sides that measure x plus 4 units. The area of this large square is the same as the algebraic expression, squared plus 8x plus 16. If you break this big square into smaller parts, you'll see why it matches the trinomial. One part is a smaller square with an area of x squared. Two rectangles each with an area of for x fit along the sides, representing the middle term 8x, and a tiny square with an area of 16 completes the shape. This visual makes it easier to understand how the middle term is twice the product of x and 4. It's like two rectangles fitting together to form the larger square. When you see it this way, the algebraic formula makes sense because it's based on the area of a geometric shape. Using this idea helps when you want to factor polynomials or solve quadratic equations. Completing the square is a method that involves creating a perfect square area, which is easier to work with. It shows that algebra and geometry are connected because both deal with shapes and areas. So, perfect square trinomials are linked to geometry because they representing the area of a square with sides expressed as a binomial. This connection helps us see the structure of these expressions and makes learning algebra more visual and understandable. It's like turning abstract numbers into familiar shapes that we can see and touch.